Hello students, today we discuss the second chapter of the electronics second paper, that is a logic gate. So the what is meant by gates or what is meant by logic gate? Logic gate is an electronic circuit which has two or more inputs but only one output. That is what we call as a logic gate. Now, what are the types of logic gates? So, there are mainly two types of gates. Number one, basic gates. Basic gates. And second type, it is a derived gates. So what are the basic gates? There are certain types of basic gates in which first is a OR gate, second is a AND gate, next is a NOT gate. These three types of gates are called as basic gates. And what are the derived gates? The derived gates are the gates which can be constructed by using all the basic gates, and that gates are called as derived gates. Naming NOR gate, NAND gate, XOR gate, XOR gate. So these are the derived kinds of gates or derived types of gates, and these are the basic gates. Now we have to study the basic gates as well as derived gates in this chapter. Again, what is the law of Boolean algebra that we have to study in this same chapter? So first of all, a question may be asked like this in the board exam for 3 marks. Question is like this: what are the gates? What are logic gates? Logic gates. Explain. Basic gates using their symbols, truth table, truth table. So this kind of question may be asked in the board exam. Now discuss the basic gates one by one. So first basic gate is OR gate. Number one, OR gate. Now each gate can be explained by means of certain parameters, namely its definition. It can be explained by means of its definition, symbol, Boolean equation or Boolean expression, then truth table and its working. So by using these 4 different parameters, we can explain each and every logic gate. So OR gate, its definition will be like this. We can define a logic gate, that is OR gate. OR gate is a electronic circuit which has two inputs or more than two inputs and having only one output. But condition is that the output of OR gate is high. The logic gate which provides high output which provides high output when one of the input is high, one of its input or both inputs are high. That means it is a condition. OR gate gives input output condition. The output of this OR gate is high only when either one or more inputs are high. So this is what the definition of the OR gate. Next, the symbol of OR gate will be like this. Symbol of OR gate. So it has here take two inputs and Y as output. A ORing with B. OR means to add. Now Boolean equation for OR gate is Y is equal to A plus B. Boolean equation of a gate is the equation which gives the output for different inputs, and this is what the Boolean equation. Next it is truth table. So to draw a truth table, we have to write all the possible combinations A, B and Y is equal to A plus B. So this is what the truth table. These are the inputs and this is what the output. So number of possible cases, it is 2n, twice n. N is the number of inputs. So 0 0, this is the first condition, 0 1, 1 0 and 1 1. These are the four possible combinations. For these input combinations, what are the output that is to be produced by this OR gate? Now we discuss these four combinations. For the output, we consider is in working, how this logic gate or OR gate working for different input combinations. Now case 1. What is case 1 here? If A is equal to 0 and B is equal to 0, what will be the output? That will be discussed by using this Boolean equation. So write down Boolean equation, Y is equal to A plus B. So addition of these two inputs, 0 plus 0, which is equal to 0. That means when A is equal to 0 and B is equal to 0, both the inputs are 0, then the output of OR gate will also 0. Case 2. A is equal to 0, B is equal to 1. What will be the output for this OR gate? So by Boolean equation, Y is equal to A plus B, that gives A is equal to 0, B is equal to 1. that means 0 plus 1 is 1. That's why we write here in the truth table 0 plus 1 is equal to 1. So this is the second case or second possible output of OR gate. Now in case number 3, if A is equal to 1, B is equal to 0. See here, when A is equal to 1, B is equal to 0, then write down Boolean equation y is equal to A plus B, that gives 1 plus 0 which is equal to 1. So in the third case, third possible combination, the output is 1. Now the last one, case 4. What is case 4? Combination will be A is equal to 1 and B is equal to 1. So write down Boolean equation y is equal to A plus B. Substitute the values for A and B, that gives 1 plus 1 which is equal to 1. So for A is equal to 1, B is equal to 1, the output of OR gate is high or it is called 1. So in this way, by taking 4 different parameters, number 1 definition, number 2 symbol, number 3 Boolean equation, and number 4 its working and truth table, we can easily understood the working of the logic gate OR gate. So ORing means to add. ORing means to add. Oh, that's like this. This is the first basic gate, OR gate. Now let us consider the second basic gate, which is AND gate. AND gate. AND means into, that is product. AND means into, that is A dot B. This is ANDing. Now how we define this AND gate? Truth table possible combination will be remain same. We consider the AND gate of 2 inputs. So AND gate, its symbol will be like this. AND, capital D. Its symbol will be like capital D. So it is AND gate. And here addition is replaced by dot, that is product. And Boolean equation makes a certain change in OR gate. So it is y is equal to A dot B. This is the Boolean equation. Now how we define the AND gate then? It is a logic gate which provides high output only when both the inputs the logic gate which produces a high output when both the inputs are high. Otherwise, all possible combinations, other combination, the output of this AND gate will be low. So that will be discussed by using working. See, this is the symbol for AND gate. This is the Boolean equation for AND gate. This is the truth table. It is incomplete. Just we are going to complete it by taking working one by one cases. Here in this case, A is equal to 0, B is equal to 0. Then according to the Boolean equation, y is equal to A dot B, 0 dot 0, which is equal to 0. So A is equal to 0, B is equal to 0. The output of the AND gate is 0 for the first condition. Similarly, in the second case, if A is equal to 0, B is equal to 1. A is equal to 0, B is equal to 1. In this way, according to Boolean equation, 0 into 1, which is equal to 0. See. So this is the second condition. Now third case, which is A is equal to 1, B is equal to 0, then according to Boolean equation, we can substitute the values respectively. Its product will comes out to be 0. That means a 1, 0 is again 0. Last case, when A is equal to 1, B is equal to 1, then by equation 1 into 1 is equal to 1. So 1, 1, 1. This is what the Boolean equation, and this is the truth table of the logic gate, that is basic logic gate and gate. So in this way we can find out the output for different combinations of inputs. This is what the second basic gate, that is AND gate. AND means ANDing, multiplying. Now next gate, a basic gate which is called as a NOT gate, which is called as a NOT gate. NOT gate. It is also called as inverter. Inverter. So NOT gate is a logic gate which produces a high output when input is low. When its input is low. When input is low. This logic gate is a gate which has only one input and one output. So there are only two possible cases in this case. It is also called an inverter because its output is exactly inversion of input, and that's why it is called an inverter. Its Boolean equation is too different. Its symbol is different one. Symbol of NOT gate is just like this. This bubble stands as an inverter. Suppose its input is A, then its output is A bar. Suppose its input is A bar, then its output is A. So we get exact inversion of input which is appear to be at output. Now truth table is like this. Only one input A and only one output y is equal to A complement, A bar. If A is 0, output is 1. If A is 1, output is 0. Working case number 1. A is equal to 0, then according to Boolean equation, its Boolean equation will be like this. Y is equal to A complement. That means output is equal to complement of input. Then Y is equal to A complement. That is equal to 0's complement, that is equal to 1. So if A is equal to 0, Y is equal to 1. And case 2, as A is equal to 1, then Boolean's equation A complement, that is 1's complement, is 0. That means when A is equal to 1, output is 0. In this way, this NOT gate is act as an inverter. It acts as an inverter. Now if we connect two NOT gates one to one or end to end, if this input is A, here it is A bar, here it is A double bar, that is equal to Y is equal to E. Double inverter, it is called as double inverter. Double inverter, or which is also called as buffer, which is also called as buffer. So NOT gate can be used as a buffer. So students, in this way we are completing the basic gates, and we will see the derived gates in the next lecture. Thank you.